Afternoon, everybody. We're going to look at multi-stage SUVAT problems this afternoon. Okay, you've done some sort of single stage ones, which is just one car, one bike, one person doing one thing. These are in multiple parts. Okay, as we go through the video, you'll need to pause, write down the questions, maybe have a go at some of it yourself, and then play again, see how you get on, rather than just me talking for 15 odd minutes. Okay. Right, if you have a look at this first question then, we've got a car that starts from rest and accelerates at a rate of 4 meters per second squared for 9 seconds. It then travels at a constant velocity for 40 seconds before applying the brakes for 12 seconds and stopping. Sketch a velocity time graph and calculate the final displacement of the car. So this is a problem in 3 parts. Okay, and as we go through, we'll be able to add more details to our diagram. So what we've got, a car accelerating at a constant rate, then travelling at a constant velocity. This will be a velocity time graph, and I label my axes, and then coming back down. Okay, decelerate into rest, and we want to find the total displacement, which on a velocity time graph is the total area under the graph. Okay, so we've got velocity, that's in meters per second, and the time is in seconds. Okay, so we're definitely in 3 parts. So if I sort of label them just 1 for the acceleration phase, 2 for the constant velocity phase, and 3 for the deceleration phase. Okay, and then just work through looking at what you know about each phase and calculating anything that basically that you can. So in stage 1, we know the car started from rest, so u equals 0. We know that it accelerated at 4 meters per second squared for a time of 9 seconds. Move that down a little bit. We can use v equals u plus at. So 0 plus 4 times 9 to find that the maximum velocity is 36 meters per second. So already I can say that after 9 seconds the car had reached a velocity of 36 meters per second. Okay. And I can also find, because we're trying to find the total displacement, it would be a good idea if I can find S at this stage as well, just the displacement for that part of the graph. And probably the easiest way to do that, given that I've got all of the numbers, is to use a half u plus vt. So that's a half of 0 plus 36, so that's 18, times 9. So that's 162 meters. So I change that to a 9. That's 162 meters. Okay, I'll label that in there. That's 162 meters of displacement in sector 1. Right, in part 2, maths is much easier. You don't need SUVAT equations because there is no acceleration. We know from the question that it travelled at a constant velocity for 40 seconds. So that's 40. If I label my axis, that'll be 49 because we were already on 9. To find the area, we're just going to do velocity times time. So S equals ut. Okay. So that's 36 times 40. So in that middle section, section 2, the car travelled 1,440 meters. Okay, we'll put that in green so it matches up with the other stuff. And then in section 3, okay, so what do we know about section 3? Well, we know that u is 36 and it comes to rest, so v equals 0. I just realised I haven't written in there 1,440 meters. And we know that it took 12 seconds to come to rest, so t equals 12. Now, I could find the acceleration, but I don't need to. I've actually got enough information to go straight to the displacement. I can use S equals a half u plus vt. I don't need a for this. Okay, so that's a half of 36 plus 0, which again is 18, times 12, which is 216 meters. Which makes sense because it decelerated slower than what it accelerated. Okay, so it took a little bit longer to stop, And all I've got to do then to get the total displacement is add up my three S values from section 1, 2 and 3. So you get a total displacement of 1,818 metres. And to finish off my diagram, I'll just put on here that it took 61 seconds in total because this extra 12 while stopping. Okay. Right, question 2. A cyclist accelerates from rest for 8 seconds at a rate of 0.8 metres per second squared. He then sees a stopped car and applies his brakes and comes to rest. If he had a final displacement of 30 metres, calculate his deceleration and the total time he was moving. Draw a velocity time graph. Well, I'm going to start with the velocity time graph because they give me an idea of what's going on. So, in this question, the cyclist accelerated for 8 seconds. 8 seconds. Okay, at a rate, so A equals 0.8. There's no mention of travelling at constant velocity for any time. It says that he immediately applies the brakes and comes to rest. So the graph comes straight back down. Okay, so T in seconds. So this is just a 2-part question this time. Accelerated and then decelerated. So we divide it up. We've got part 1, the acceleration phase, and part 2, the deceleration phase. Same again, just list what you know for each of the parts. Okay, so we know that U equals 0. We know that A equals 0.8, and we know that T equals 8. So if I use V equals U plus AT, we get 0 plus 0.8 times 8, which is 6.4 meters per second. So the maximum velocity that he reached was 6.4 meters per second. That's going to come in handy when we have to work out part 2. Okay. It's probably a good idea to also work out how far he travelled, because we have this information that says that altogether he travelled 30 metres, so it would be useful if we know how much of that 30 metres was used up while accelerating. Okay, so we can use half U plus VT now. U plus VT for this. I know we've got the acceleration, but this is probably the easier equation to use. So U is 0. V was 6.4 and that was 8, so that's really 3.2 times 8, which is 25.6 meters for the displacement. Right, so we've now got lots of information that we didn't initially have to help us on section 2. So for instance, we know that U is 6.4. We know that V equals 0, okay, and the other information which is not immediately obvious, but we also know the area of that second triangle, because his displacement was 30 metres, we've just calculated that he used 25.6 metres getting up to speed, so it must be that he took 4.4 metres to stop. Okay, so if listing what we know then, U is 6.4, V is 0 and S is 4.4. He stopped quite quickly, I mean, as you would if you're about to cycle into the back of a car, I suppose. Okay. Right, from that we need to find T and A. Okay, it doesn't really matter which way around you do this. If I do A first, we've got V, U and S. We're trying to find A, so it makes sense to use V squared equals U squared plus 2AS. Okay, putting our numbers in, so V is 0, U squared is 6.4 squared, we've got the 2S, we haven't got an A, but 2S would be 8.8, so 8.8 A. To calculate A, you would need to move the 6.4 squared to the other side, divide it by the 8.8, you should be able to get the acceleration is minus 4.65. That is a little bit rounded. 3 significant figures is fine. Okay, so that's a sharp deceleration. Okay, and then the time he was moving, well, if we use S equals a half U plus VT, which I use a lot, you can use any of the equations really because you've got all the information you need, but because I rounded A, I'd rather not use A in another calculation if I can get around it because of accuracy. So we've got 6.4 and 0, so half of that is 3.2. Okay, we also know the displacement was 4.4 and we're trying to find t. So 4.4 divided by the 3.2, the 3.2 is coming from this bit here, like a half of 6.4 plus 0. So 4.4 divided by 3.2, you get a time of 1.375 seconds to come to rest. Okay, so that puts us on altogether time-wise 9.375 seconds. 8 seconds to accelerate, 1.375 seconds to stop. So the total time equals 9.375 seconds. It's those 8 plus this 1.375, and that's that one done. And the graph fills itself in as you go rather than leaving the graph till the end. Okay, it helps if you can visualize the problem in graph form anyway, so I'd get a sketch of the graph and just add numbers as you go along. Okay, my last example then, before you do a few on your own, is about a train. So it leaves the station, accelerates for 16 seconds to a maximum velocity of 24 meters per second. It then continues at this velocity until it approaches the next station. The train then decelerates at a rate of 1 meter per second squared before coming to rest. If the stations are 6 kilometers apart, for how long does the train travel at a constant velocity? So a little bit similar to the first question of today's video. Look, it's a 3-part question. The train accelerated, travelled at constant velocity, and then came to rest further down the track. So a 3-part question again. So let's just get my graph ready and I'll add bits to it as I calculate them. So we got step 1, step 2 and stage 3. Okay, so that's 16 seconds. We know that this is 24. And we also know from the bit in red the total displacement, and for our graph the total area is 6,000 meters, 6 kilometers. Okay, if you know it, it's probably for a reason. Okay, and we've also got here that A is -1 because we're decelerating. If you put it in as 1, it'll all go wrong, the train will never stop. Okay, section 1, let's have a look at what we know. So I can move this down now because there's nothing in the question that isn't on my graph. Okay, in section 1, we know that V is 24, we know that U is 0, we know that T is 16, and I don't think A is particularly going to help me, but I can find S. I got U, V and T, so it makes sense to use them. U plus V, T. Of course you could find A if you wanted to. It's probably not very nice and therefore it's not going to be very accurate. Put it in the numbers then, so a half of 0 plus 24, which is 12. 12 times 16 is 192 meters. So the train takes 192 meters to get up to speed. Section 2, we don't know a lot. It's constant velocity, so V is 24. We don't know S, we don't know T. So I made a little bit of a mess of that. Hang on. Don't know T. So what can you do with section 2 at the minute? Not a lot. So let's move on to section 3. You don't always work in order, and that's why I've got this example to show you. We know quite a lot about section 3. We know that U is 24. We know that V is 0. We know that A is -1. That's that's 3 things. That's enough to get us going. So let's go to that. U equals 24, V equals 0, A equals -1. Using V equals U plus AT, I can find T. I'm not going to get very far in this question without T. So V equals, so 0 equals 24 minus 1t. To solve that, bring the 1t over to make it positive, and if 1t equals 24, then t equals 24, doesn't it? That's easy maths there. Okay, and now I've got t, I can use my s equals half u plus vt equation. You can get s without t if you use v squared equals u squared plus 2as. Okay, so that's a half of 24 plus 0. Dear, mistakes in this one. A half of 24 plus 0 times 24, and 12 times 24 is 288 meters. Okay, does that help us then on section 2? It does, as long as you haven't forgotten that we know this. Okay, that the total area of the whole graph, the total displacement, is 6,000 meters. Well, we've got 192 meters in section 1 and 288 meters in section 3. That's 480 meters of travelling, of distance, displacement, which means there must be, by taking that away from 6,000, this must be 4,520 meters. And just taking away the displacement of 1 and 3 away from the known total 6,000. Okay, so now I've got all the information I need down here. So 4,520. Time is distance over speed, or displacement divided by velocity. So if you do s divided by v now, you'll get 188.3 recurring seconds. So how long was the train travelling at a constant velocity? Our final answer is there. Okay, 188.3 recurring seconds. I could even add up the total time it takes for the train to go between the 2 stations. If I added up that 16, that hasn't come out very well, that 24 and the 188.3. Okay, but the question said how long to travel at constant velocity, so that is actually our answer there, 188.3. And that's how you take on a multi-stage problem. Okay, a velocity time graph always helps, even if you can't particularly label a lot of it to begin with. Okay, so I'd always get a sketch in. You can add the numbers as you go along. You don't necessarily work in order. Okay, sometimes you know more about section 3 than you do about section 2, or more about section 2 than section 1. So if you feel like you haven't got enough information, maybe go and have a look at one of the other stages or sections and see if that helps you fill in some of your gaps. I'll post some questions on a separate worksheet for you to have a go at, and a Google form for you to type your answers into, and hopefully this video has given you enough to get going.